provider company, right? We have a service provider. We can say the internet service provider as well as. So we have a Cisco company, and Cisco has a multiple branch office in the India. So for example, Cisco, we have a Delhi, Cisco, we have a Mumbai, Cisco, we have a Bangalore, and Cisco, we have a Hyderabad. And what happened, this branch office, right? All this branch office has connectivity with the to the different branches through the service provider. We can see that as we can take a MPLS connections, or normally I can go for the ISP as well as, right? Doesn't matter, it's not a big deal, right? I can get a connectivity through the any of them. But my all this branch office, we have a different in the different cities are there. Now the thing is that this service provider company is going to run with a protocol that name is OSPF. This guy is running with the protocol that name is OSPF right now. But the problem is that under this internal network, right? This internal 1.0.0/8, we have a 6.0.0/8, we have a 7.0.0/8, or 2.0.0/8. These are my internal route, right? This internal route, sorry, these are my internal route, and this internal route are advertised into the EIGRP routing protocol. Okay, try to understand what's problem is happening right now. So we have running with the OSPF on this particular OSPF is enabled, this particular OSPF, and the complete R3, R4, R5 router. This is the OSPF is enabled, and also this interface, the 56.0 subnet and 57.0 subnet. This guy is also enabled with the OSPF. But the thing is that all this my internal route, whatever the internal route we have, like 6.0, 7.0, 1.0, and 2.0, this guy is running with the EIGRP routing protocol. So in this case, what happened? First of all, you need to perform the redistribution on every router, right? Try to understand. You need to, the first issue we'll have, if you exchange the route, or we can see that if the user are sitting behind the R6 or the user are sitting behind the R1, we can see the Delhi to the Bangalore. If you provide the communication between this user to this user, what happened? We need to exchange the routing information, the basic thing. We need to exchange the routing information, right? To exchange the routing information, what we have to do on this guy? We need to perform the redistribution on this router, this router, this router, and this router. Why? Because my internal route, right? My internal network is running with the EIGRP routing protocol. My internal network is running with the EIGRP routing protocol. My WAN connection is running with the OSPF. So if you provide the communication between these two guys, EIGRP and OSPF, you provide the not provide, if you exchange the route between these two protocol, what happened? We need to take a help of the another person. That name is a redistribution. Okay. So now we have a solution, right? We can perform the redistribution on R1 router, R2 router, R4, R6, and R7. After that, what happened? Try to understand. After that, you are going to exchange all information, right? All the information are going to exchange this information through the service provider network. All this information you are going to exchange through the service provider network, right? Of course, if I'm going to advertise this, take example of this person. Take example of this person 1.0.0. This guy is running with the EIGRP, right? If I'm going to redistribute into those, what happened? On this R3 router, what happened? You will have this information as a E2, right? That's a default behavior. Same thing 6.0 as coming with the E2. 2.0 is coming with the E2, and 7.0 also coming with the E2. And R3 need to share this information to the R4, and R4 need to share this information to the R5. So inside the service provider network, whatever the routers we have inside the service function, it means that now this customer, the Cisco, we have a customer branch, we have a Cisco. Cisco is going to share the own LAN information with the service provider. That's not a good thing. According to the security perspective, this is not a good thing. You are sharing the own information to the service provider. According to the security, this is not a good thing. You are going to share this information to the service provider. But the problem is that we need to share. We need to share because right now we are doing the underlay routing. Underlay routing in the sense of what? we have to exchange all the routing information, right? We have to exchange all the routing information through the, take example of this person 6.0.0. We need to share this information to the R5. R5 will share this information to the R4. R4 will share this information to the R3, and R3 will share this information to the this guy, and this guy as well as. Everything we have to do under day. So in this case, we need to share this information, my line information, to the service provider. The first issue is happening. Issues one. What happened?
Sir, this VO iOS 3, V iOS 5, right? Those are ABRs?
Yeah. No, it's the same areas. Swami, can you see that same area is running over there?
Oh, same area.
Same area.
Okay.
Nothing
Yeah.
is. So need redistribution over there, right? So of course, if I'm going to perform the redistribution on this router, this guy will become the ASBR router. This guy. If I'm going to perform the redistribution. Now, what happened? The second thing. Second thing is that now customer information and what do you think about the ISP and service provider? Service provider and ISP, in a simple language, this is the public. If I want to talk about the ISP, it's a public, and service provider is a private, right? Private cloud and public cloud, we can say that. Still, you're sharing the own information, own customer information to the different companies. This is the two issues happening right now. The biggest issue, redistribution. Second issue, customer information has to share with the service provider. Now, the third issues, are you getting any kind of end-to-end single routing protocol over there? No. I'm not getting end-to-end single routing protocol. My question is that, can I get I can exchange my direct information from there to that? No, I can't get it. End-to-end direct connectivity of end-to-end is not there in this case. Direct connectivity between the end-to-end is not there in the normal routing. Because everything we are relying on which guy? Underly. We cannot use the same protocol to exchange the routing information. We cannot say right now, till this point, what happened? We cannot share this information 1.0 directly to this guy. Yeah, yes, we have a solution. We can use the GRE over there. We can use the MGRE, and we can use the DMVPN as well as to share direct information between this guy to this guy. Just make a one tunnel. I'm just going to make a one tunnel between this guy to this guy, and this guy to this guy. And through the tunnel, I can exchange my information. Through this tunnel, I can exchange this information 1.0, 6.0. But we need to perform the extra overhead on the router. In this case, what happened? You are just deploying a overlay routing. So already we have underlay. We need to create another topology over there. But again, what happened? We need to either implement the GRE, MGRE, DMVPN. And that require a huge amount of configuration. In that case, what happened if I'm going to implement this VPN features? In this VPN features, what happened? No need to perform the redistribution. No need to perform the redistribution. At the same time, what happened? At the same time, what happened? The customer information will be not shared to the ISP. So by using this solution, right? Listen to me. By using this solution, I can resolve all these issues. But what this problem is getting over there? What this guy is going to create the problem? This guy is going to create the problem. Lots of configurations. So to avoid all this kind of problem, what we have introduced the concept of EIGRP over the top. Also known as a EIGRP OTP. As the name suggests that over the top. What's the meaning of the over the top over there? So this is my underlay network, right? This is my underlay network. So through this network, what happened? I'm just going to create a new overlay network. Through this network, I'm just going to create a new overlay network between branch to branch. That's the meaning of over the top, right? And this just is only happening in the EIGRP. So in this case, what happened if the customer side, right? If the customer side is running with the EIGRP, and if this customer side is running with the EIGRP, this guy has the ability to create a new overlay network. So I can create a like this overlay information, right? I have one network over there like this, like this, like this, like this. So something my topology will look like this. I can say that router number 1, router number 6, router number 2, and router number 7. They are connected like this. Full miss. So this is my underlay network. What I'm getting over there by using the over the top, I'm getting the overlay. Now tell me one thing. If I'm going to create an overlay network, do I need to perform any kind of redistribution over there? No. I can directly share my this information to this guy. I can directly share this information to this guy. I can directly share this information to this guy. Our own information 6.0.0. I can directly share this information to this guy. All the router is going to exchange their own information. Every router. So tell me, do I need to share this line information to the service provider now? No. Do I need to perform any kind of redistribution? No. The good thing about the EIGRP over the top, you can create a overlay network. You can create an overlay network, and in that case, you don't need to depend. In that case, you don't need to depend on the they are running with the ISS, BGP, OSPF, RIP, EIGRP has a different AS number. Doesn't matter. I'm not to depend. It's totally a independent topology. I'm not going to share any single information now. R1 can share the direct information to this guy. R1 can share own information directly to this guy, and R1 can share own information directly to this guy. I'm not going to share this information 1.0.0/8 to the service provider. No, I'm not going to share. I can directly exchange my information to the over the top. It seemed like your DMB seem like your DMVPN, GRE or MGRE. What is the use of DMVPN, MGRE or GRE? They are just going to provide the site to multiple site connectivity, right, over the public and private cloud, right? Same thing over the top is going to do over there. But in this over the top, what happened? This is the features of the EIGRP that is introduced by the Cisco. So in that case, I'm not going to depend. This customer is not going to depend on the service provider network. They can directly exchange the all information over there. So you can implement the EIGRP over the top in the two ways. Either you can do the full mesh topology, or either you can make a route reflector. Hey guys, try to understand this full mesh and route reflector. The same term is also coming for the IBGP as well as, right? So don't confuse with this full mesh and route reflector. I'm going to talk about the perspective of the IBGP. This full mesh and route reflector is for the part of the EIGRP over the top, not for the IBGP. So EIGRP has also a route reflector mechanism, ERR, EIGRP route reflector. So you can implement the over the top in the two ways. Either you can create a full mesh topology, or either we can create a route reflector. For example, if I'm going to do the full mesh, we have a look like this, R1. Then we have a router number 6. This is the overlay network that I'm creating over there, R2 and R7. So every router has a connectivity look like this, like this. This is the full mesh. And how the router reflector will work over there? So we can make a one router 1, router number 2, for example. This is the Delhi branch. This is the Mumbai branch. We have a 6, router number 6. That's the Bangalore, and this is the Hyderabad. What I'm going to do, I'm just going to make this guy as a ER route reflector. So what happened? R6 is going to form the neighborship with R1. R2 is going to form the neighborship with R1, and R7 is going to form the neighborship with the R1. And this neighborship that you are forming, this neighborship will be done by the unicast neighborship. I'm not going to form the multicast neighbor dynamic neighborship over there. I'm going to form the static neighborship. Of this term, I can say the unicast. It's a static neighborship. So basically, we have two types of neighborship. One is a dynamic neighborship, and one we have static neighborship. So how dynamic neighborship is working on R1 and R2? What happened? We just need to put the network statement, network 0.0.0.0.0 and network 0.0.0. They will exchange the hello packet, and based on the hello packet, they are forming a dynamic neighborship. But here I'm not going to advertise this information. Here I'm going to form the static neighborship. Because dynamic neighborship you are forming between the directly connected route. Dynamic neighborship you are forming between the directly connected route. For example, this is the router number 1, router number 2, 12.0 subnet. You are forming a dynamic neighborship between this guy. Both are present. Both this router are present in the same broadcast domain. But right now, what happened? The users are present in the different broadcast domain. This guy has different broadcast domain. This guy has a different broadcast domain. This guy has a different broadcast domain, and this guy has a different broadcast domain. We need to form the static neighborship. So you can implement the EIGRP over the top in the two ways. Either you can go for the full mesh, or either we can go for the route reflector. So if you're doing the full mesh, you will have a look like this topology. And if you do the route reflector, you will have a look like this topology. Same route reflector works like a IBGP route reflector. So this is my underlay network, right? This is my underlay network, this one, and I'm getting the overlay like this. This is my overlay, and this is my overlay. Depend on the requirement, you can implement the full mesh or all good. So let's do one thing. Let's first discuss about the full mesh. Okay. Let's so EHRP on the top is better or VPN or GRD. I'm coming to that one, Jadip. Just give me some time. Okay, I'll come into this one. Right? I'm going to this one at the end of the day, right? And then you will decide, right? So which one is the better, right? Over the top and the DME pin or GRE. So guys, this is our topology, right? So same like this diagram. So So I'll tell you the first thing. I think on the GNS3, if you're going to do this practical, is not there in the EIGRP over the top, right? And this EIGRP over the top, you can only implement in the named mode. This feature is only applicable in the named mode. Okay, so you can do this practical in the web IOU or EVNG, right? So this my topology, the same one. Like I can do one thing. Let me take a console access of this guy. So all my routers is started. Start this guy. Okay.
So this is this web IOU you using?
Sorry.
Is this web IOU?
No, it's a EVNG. PNet lab is there. It's a EVNG. Web IOU, you don't know the web IOU? I'll show you this thing. Okay, after the batch. Okay, what happened?
GNS3, are we able to do this thing?
You can't do this practical in the GNS3 because GNS3 does not support this thing, right? Okay, what's
Okay.
happening?
Okay.
Okay. 149.
Law, is EVNG running on any of your VMs in Netmetric? Networkers, I'm sorry.
EVNG, yeah, actually, I'm taking a remote access of the Eve. So some servers are present in a different location. So I'm taking access of this one from the different. This is not present in the itself in the my laptop right now. Okay.
Correct. So what I want to
I'm
know is
taking
like,
access of the server, right?
can we VPN into Networkers home and then basically try doing this lab?
Yeah, yeah, you can. Okay, you can do that. Don't worry, I'll give you the providing this access as well as. Don't worry about that.
Okay. Because I don't have
Okay.
EVNG. I have a GNS3 on my laptop. So.
Also, you do one thing now. You 1 minute. I'm going to start my devices. Yep. So I'll do one thing after the batch now. I'll give you the one number. Just call that person, right? He will help you to install the EVNG as well as. Okay. If you want a PNet lab, they can help you in the PNet lab as well as you can install this thing. All good. R3. Then we have a R4. And I'm telling you guys, if you have a knowledge of the DMVPN, and now after that you can analyze which one is the better DMVPN EIGRP or the OTP is providing a its ultimate level of the features of the EIGRP, right? It's a great feature of the EIGRP. It's not coming in the examination, right? But for the knowledge purpose, it's very, very important. In examination, it's not there, OTP. I don't think so. In the CCIE Enterprise syllabus, OTP is there. I'm not seeing. So I'll show you the first full mesh over there, and then we'll go for the router data as well as. So guys, I'll show you the first. Okay. So I'll show you the first R1 configuration. This is the router number 1. So I'll show you the first configuration R1. Show IP interface brief. Right, we have a already 13.1. This guy's configured, right? So same network I'm going to use 13.0, and we have a one loopback that's behave like a LAN network of R1. And if you see show IP protocol summary, so I have OSPF is enabled over there, right? So all this route has advertised in the OSPF like this topology. Okay, this one same. So it seem like a OSPF is enabled over there.
So you can do show IP
So if you see the
OSPF
show running
interface brief
config of
for that.
OSPF, yeah. Voice is very okay. That's fine. So now if you see, my router OSPF configuration is there. So what happened? Okay. So if you see this configuration router OSPF 1, I'm going to advertise this network right on the router number 1. The same configuration, this same configuration is done on every single router. On every single router, same OSPF configuration is there. So if you go for the router number 2 as well as enable, so IP interface brief, so IP protocol summary, and so run section OSPF. All good. So router number 2 also we have the same configuration, right? On a router number 3, if you go, enable the router number 3 is behave like an ISP, right? So IP interface brief. Right. So all they have a configuration on the gig 0/0. And if you see the so run section OSPF, same configuration I did on R3 as well as. All good. Go back to the router number 4. Enable. So IP interface brief. Show run section OSPF. Everything is good, right? If you go back to the router number 5, that is my this provider edge, this ISP. This is the provider edge router, right? So IP interface brief and so run section OSPF. So this is my provider edge router, this is my provider edge, and this is the P router. So we can like this P provider edge, and this is my P router provider, core provider router. So provider edge means what? This guy is going to provide the connectivity between the customer to the provider, customer to the provider. This is the core provider router. They don't have any connectivity with the customer. All good. So if you go back to the router number 6 as well as, that is this guy, right? Enable so IP interface brief, so IP protocol summary. Okay, EIGRP is let me remove this EIGRP, no router EIGRP. Okay. See what the pre-configuration is. No router EIGRP CCIE. All done. Save this configuration. So all good. If you see the do show run section OSPF, do show run section OSPF, you can see that I have OSPF configuration, right? That's I'm only going to advertise my 56.0. Oh, sorry, this network. That's my directly connected to the ISP, right? And now we have last router number 7, a different branch office. So let me change the host name first of all. This guy, host name will be R7, and do show IP interface brief, do show IP protocol summary. All good. And I have OSPF, do show run section. All good, right? So now let's enable the EIGRP over the top. How I can do that? I just need to go on the router number 1. So I'm only going to enable the EIGRP on this router, this router, this router, this router, like this. Where is that? This one. So I'm going to enable the over the top on this router, router number 1. That's our Delhi branch, Mumbai, Bangalore, and Hyderabad. I'm not going to run the EIGRP on this guy. And EIGRP, I'm going to advertise my LAN information as well as. So now let's do one thing. I need to configure the EIGRP named mode over there because the OTP is only work with the named mode. So on the go on a router number 1, on a router number 1, this guy, router EIGRP, put the any name, I'll say the network of homes, right? Address family IPv4, define the autonomous system number 1. And now what happened? I need to form, right? I need to form the neighborship. I want to do the full mesh configuration. You can implement your EIGRP over the top in the 2 ways. Either you can do the full mesh or either you can do the route reflector. Right now, I'm just going to focus on the full mesh, right? In a full mesh, what happened? I need to form the neighborship with this guy, this guy, this guy, like this. This guy is going to form the neighborship with this person, then this person, right? And this guy to this guy as well as. This is the full mesh, right? I'm going to implement the full mesh over there. So what I can do, I'm just going to say that, hey, router number 1, I'm going to form the neighborship with whom? So R1 is going to form the neighborship with the 23.2. So the source over there right now. So I'm going to form the neighborship with the 23.2. So what will be the source? So this will be the source and this will be the destination, right? So what I can say that neighbor, I'm going to form the static neighbor 23.2, right? And after that, what happened? I need to inform, hey, my source will be gig 0/0. This is my source because I'm forming the R1 and saying that, hey, I'm going to form the neighborship with the 23.2. In that case, what happened? My source will be gig 0/0, right? Now, after that, what? After that, I need to define the remote keyword, right? Because I need to tell this person, hey, my neighbor is my remote, right? This is my remote neighbor. This is my not directly connected neighbor. This is my remote neighbor. Done. So what I'm going to tell this person, hey, this is my remote neighbor. And after that, how many hops away this guy? You can define your hops from 2 to 200, right? Why one is not given over there? One is for the directly connected, right? One is for the directly connected. One is for directly connected, right? So you can define your hop from this range. How many hops this? I can go for the 5 as well as, right? Then most important protocol. LIPS. What is the role of this protocol? I'll tell you. It's a you can use the DMBPN, GRE, and MGRE. What this guy is going to do? This guy is going to provide the overlay network. Is going to provide the overlay network. Data traffic with LIPS. Otherwise, what happened? I'm sending from here to facing this. No, it's breaking for me as well. So you have to inform me, guys. 1 minute. 1 minute. Let me check. So my third issue is there maybe. Now it's clear. Hope this thing's clear. It's clear now. Yeah. Thanks. All good. Good one. Exactly. Now it's good. Okay. I don't know for later. So now try to understand why do we need of lifts over there? If tell me one thing, if I'm going to create a source IP address 101, the destination 6.6, I'm pinging from R1. What happened? R1 is going to perform the destination lookup, right? By default, router is going to do the destination lookup, and according to the R1, where should this guy is going to forward the packet? This guy, R3. Does R3 have this information? No, because in the over the top, what happened? The service provider does not have any idea of the customer route. In over the top, what happened? The service provider does not have any idea of the customer route. So in that case, what happened? I need to encapsulate my packet. I need to say that, okay, this is your packet. I need to encapsulate this packet with the lips, right? And after that, I'm going to put the source IP address. The source IP address will be now this guy, because here I'm going to form the neighbor shift from this guy to this guy 56.6. This encapsulation is done by the lips. And this guy is going to use the protocol that's named on the UDP. It works on the UDP 4343. I think so, 4343 or 42, 4343. The port number. So in this case, what happened? The source information, the source packet, the source port number will be random port number, anything's 1, 2, 3, 4, 5, 6. Destination port will be 4343. Still, my packet will go by like this. So what happened in this case? The router is going to forward the packet based on this one, not based on this one. They don't have any idea. The service provider is not going to look up for this guy. Because this is my public network, right? This public network, this public 13.1, that is this guy is enabled with the OSPF, right? And 56.6, this guy is enabled with the OSPF. So every router has the information of this person, right? So this encapsulation I need to do by the LIFS. So LIFS stand for locator identifier separation protocol, is something like this. 1 minute. EIGRP over the top. Just go. Yep, I can get this one. Just not giving the LIFS full run. I'm doing the LIFS. Just go. It's a locator ID separation protocol. I'm telling you, it's a very, very big protocol. I'm just giving you the overview how the LIFS is going to work in the EIGRP over the top. It is just going to use the encapsulation over there in the EIGRP in the OTP. But itself on the LIFS, I have one book that's almost 700 pages of the book on the LIFS only. So this is a big technology in the data center. This guy is coming the LIFS, right? In the data center, this LIFS is coming. It's a very big technology. EIGRP over the top is going to use this technology to just encapsulate my data traffic. So here in the EIGRP over the top, the LIFS is behave like a data plane, not the control plane. In EIGRP over the top, LIFS is behave like a data plane. So now my all traffic is going to be encapsulated with the LIFS. So I need to inform this person, neighbor 23.2. The gig Ethernet I'm going to use this guy 0/0. Remote will be what I can go for the maximum 5 hops over there. Then I need to use the LIFS encapsulation protocol. Once we have done with the LIFS encapsulation protocol, each LIFS is going to have a separate identifier. It will create a one domain, and that domain has a separate identifier like a logical domain. So you need to put the identifier of the logical domain as well as. You can take any domain number. I can go for the domain number 1. You can go for the 10 as well as. Now the same thing I need to put, because I'm going to make a full mesh. I need to create this section with the 56.6. That is this guy. I'm present on R1 right now, so I need to make a 56.6 and 57.7.7. Remote, I can go the 5 hops over the ellipse encapsulation 1. Same thing and neighbor 57.7. Gig 0/0 remote will be 5 and ellipse will be 1. Same thing, I need to go on the router number 2, this guy. What happened? This router is not working. Okay, connection is disconnect. Why? This guy also connection disconnect. Actually, I changed my internet. That's why. 1 minute. I'll take another router number 2. So 3 is there. So 4 is not there. So let me remove the 4 as well as 5 is there. Not 6 and 7 also not there. So let's do one thing. Let me take a R2. Enable config terminal. So I said that do show run section OSP. Let's take the OSP over there. All good. So router EIGRP NH address on IPv4 autonomous system number 1. I'm going to say that neighbor. I'm going to form the neighborship with the 13.1. That I'm going to use the source will be gig 0/0. Remote will be, I can go for the 5 hops. You can go any hops, but don't go for the lower number, right? And then after that, we need to ellipse encapsulation ID. I'm going to use the 1. Same thing I'm going to do with the 56.6 because I'm going to make a full mesh over there. Gig Ethernet 0/0. Remote will be 5 and ellipse encapsulation will be 1. And same thing neighbor 57.7. Gig Ethernet 0/0. Remote will be 5 and I'm ellipse encapsulation 1. Done. Now let's go back to this guy now. Router number 6. Enable config terminal router EIGRP address family autonomous system 1. I say the neighbor or turn it on 1. Then I say the source will be gig Ethernet 0/0. Remote will be 5. The hops I'm going to define ellipse encapsulation ID will be 1. Neighbor I'm going to form with the 23 or 2 as well as. That is this guy, right? So gig Ethernet 0/0. Remote will be 5 and ellipse encapsulation 1. And neighbor I'm going to say that 57.7, that is the R7. And as the gig Ethernet 0/0 remote will be, I can go for the let's 3 remote, right? And ellipse encapsulations 2 over there. 1. So I go for the 3 hop away because it's my nearby. R6 is nearby R7, right? So I just go for the lower hops as well as router number 7. Enable conf terminal. I said router EIGRP number NH address can be IPv4 autonomous system 1. Neighbor I'm going to form the neighborship with the 13.1. Okay, and then I'm going to use the gig Ethernet 0/0 source. Remote will be 5 and ellipse encapsulation will be 1. Neighbor I'm going to form with the 23 or 2. Gig Ethernet 0/0. Remote will be 5. Ellipse encapsulation will be 1. Right, neighbor I'm going to form. Okay, I know why this error message is coming to away. 56.6. Gig Ethernet 0/0. Remote will be 5 and ellipse encapsulation will be 1. Do show run section EIGRP. Now I'll explain you this why this thing is happening. Don't worry. I didn't define this guy, right? I didn't define the network 57.0.0. I didn't define it. If you go back to the router number 1 as well as I haven't advertised the 13.0 as well. If you see, I haven't advertised. Okay. If you go back to the router number 2 as class, I just formed the new share. I haven't advertised my this network, right? Right. Also, is there network 23.0? I just performed this configuration right on a router. If you go back to the router number 6 as well as, if you see, I haven't advertised this route. I just configured this person, right? Now try to understand. If you just see the neighborship, so IP, EIGRP neighbor, I have a good neighborship, right? Let's do one thing. Let's advertise my LAN information now. All done. Network 6.0.0.0, right? Router number 7. Network 7.0.0.0. Router number 1. Network 1.0.0.0. And router number 2. Network 2.0.0. Now, if you just go back to the router number 1, that's this location, right? I'm present this location I'm talking about. Which location is this? This is Delhi, right? Just show IP root EIGRP. Can you see? I'm getting all this information. If you go back to the router number 2, I'm having the EIGRP information, right? And if you go back to the router number 6 as well as, router 6 also have a complete information. And if you go for the router number 7, router 7 also have a complete LAN information. Try to understand ISP. Do we have any information regarding the 1.0, 2.0, 3.0, 1.0, 2.0, 6.0? No. They don't have any information. The thing is that right now, what happened? I made this topology, right? Like this, router number 1. This is the router 1. Router number 6. Router number. I'll do one thing. I'll make it over there. I'll make this like this. Router 1. Router 2. 6. 7. 1. 6. 2. 7. How they are connectivity? How they have a connectivity? Like this, like this, like this, and like this, like this, and like this. Full mesh. The branch location. So Delhi, Mumbai. So this is the Delhi. So this guy has a 1.0.0.0. Mumbai. This guy has a Bangalore. And this guy has a Hyderabad. So can you see, is there any ISP comes in the picture? This is my overlay network. And that is done by through the OTP. So you can now compare this topology with this topology. Can you see? This is my underlay. This is my overlay. So how the route action is happening? I can directly send my this information to this guy. I can directly send my this information to this guy. I can directly send my this information to this guy. The 1.0. Did I configure any kind of MGRE? I'm coming to the point as well as 1 minute. Hold on, I'm coming to the point. Then exactly, it will be a one hop away. Did I configure any MGRA and DMP pin over there? No. This is the benefit that you are getting after creating the EIGRP over the top. So the complete customer, try to understand. Right now, this service provider is behaved like a transparent. In this case, does customer is going to depend on the service provider? No, doesn't matter. Customer does not have any issues, right? What protocol the service provider is going to use, because even I'm not going to share my information to the customer. I don't need to perform any kind of redistribution over there. Everything I can exchange over there in the full mesh. Now, if you see on router number 1, let me capture this link. I'll show you the data packet. डर हो जाता है आपसे मुझे पता नहीं. So now you बताता हूँ. Now if you see, guys, can you see my hello packets over there? If you open any hello packet, Cisco EIGRP, what happened? This is the 56.6. That is the this guy, right? This guy is a 56.6. Is sending the hello packet to whom? 13.1. Do we have any extra information in the Cisco EIGRP? No. The same thing is happening, right? The flags are same. The conditional receive flag, init flag, or the restart and the end of the table parameters are same. That I'm going to use the hold on RAM. The TLB field, the software version that is used for the management purpose, right? Everything is same in the hello packet. Nothing is different. The interesting point is over there. This hello is a unicast, right? This hello was the unicast because I'm sending the packet from the 56.6 to the 13.1, right? This is the complete unicast hello, right? Now try to understand. I said the ping 6.6.6.6.6 source 10111. I have a good communication, right? If you see the packet right now, let me close this guy. The data plane packet I'm going to show you. ICMP, I'm interested right now. Okay, I not the ICMP UDP, I think so. Yep. This was the packet that I'm sending, right? If you see, I'm just going to ping because the encapsulation will be done by the LISP and LISP works on the UDP. So if you just go to terminal and send the multiple packets, so you can see the packets are sending over there. I simply will be not there, the packet will be UDP based. Sixth, source, repeat. Can you see the packet is moving on? And if you open any of the packet, take example, what happened? The reply is coming, right? Source is 56.6. The R6 is giving the reply 56.6 is source. Destination was 13.1. Right? So do we have what ping I did over there? If you see the ping that I did, I created this packet, right? I'll do one thing. Let me capture this packet. 1 minute. I'll show you the run the trace route as well. Just give me 1 minute. Let me clear this point.
Sir, how is source 56.6?
Reply आ रहा भाई.
अच्छा reply है वो. Okay.
इसलिए मैंने बोला just give me 1 minute. Let me clear this point. Okay, otherwise you will get confused. Now see, I'm pinging from this router number 1, right? So I'm pinging router number 1 to the this guy 6.6.6 to the 101 source will be 101, right? So in this packet will look like this. 101 is source, destination was 6.6.6.6.6, right? When this packet is coming to the router number 1, router 1, when this packet is coming to the router number 1, what router 1 is going to do? He said, hey, do we have a destination 6.6.6 in my routing table? Show IP route. Yes. According to the routing table, I have this information 6.0.0.0, right? And my routing table is saying that I need to forward the packet to whom? 56.6. I need to forward the packet to whom? 56.6.6. On which interface I need to forward the packet? So I need to encapsulate this guy with the LIPS, right? In the LIPS, what happened? I'm going to use the source port number, will be anything, any random number, a random port number, because LIPS is going to work on the UDP. Destination port what? 4343, right? So what will the source IP address, destination IP address over there? So now the destination will be 56.6. And how do I reach to the 56.6.6? To reach the 56.6.6, I need to use this guy, right? I'm going to exit the packet from this interface gig0/0. So on the ISP side, this header will be lookup, not this one. Same packet is happening right now. You see, 13.1 source, destination 56.6.6. This is the public information, right? The private information is totally hidden. It's totally hidden. Hidden part. The source port random I can use over there, and destination 4343. So do we have any ICMP over there? No, all my information will be encapsulated with the UDP, every single packet. So if you see the internet product layer 3 information, right? What this guy is saying that, hey, forward the packet to the UDP. He's not saying that the forward the packet to the ICMP 1, right? It's saying the forward the packet to the UDP, and UDP on the layer 4, right? And the layer 4, what I will source port a random destination port will be 4343. That's used by the LISP OTP. So now if you make a trace route as well as to just see how many hops away this guy. Okay. Trace route 6.6.6.6 source will be Ron, clear now?
Yes, thank you.
That we want to hop, right? What I told you that this guy is totally hidden now. This guy is totally hidden. One hop away, right? Just a one hop away. If I'm going to make a trace route from here to here, how many hops away? One hop away. Doesn't matter how many routers you're going to put in the service provider. This is totally hidden part now. Totally hidden. Don't worry, guys. If you have a more any question about the LIPS is same like an overlay protocol. It's an encapsulation protocol right now. Okay, so it encapsulation my protocol, and in the LIPS, the role of the LIPS in the OTP is behave like a data plane. So if you're sending any packet, all the packet will be encapsulated with the LIPS. So if you have any question about the for the LIPS side, how this thing is working, so don't worry. I have a one separate practical on the LIPS as well as what is the role of LIPS actually. Okay, how the LIPS is working, everything. I have a separate practical on the LIPS as well as I'll show you that thing as well. We'll go through how the LIPS is working and why we have introduced the LIPS. I'm telling you, it's a great feature of the LIPS, right? It is going to reduce the size of the routing table as well as on the service provider side. So we'll discuss the LIPS as well as, but my focus is right now OTP.
I think Lisp is used in that SDA architecture, right, sir? SDA, which is
right. This is a guy how you can create a full mesh. So hope this thing is clear to all of you. So let's go for the router to as well as. एक मिनट मैं 3 सेपरेट वीडियो बना लेता हूँ, सही रहेगा. Okay, I saved that one, right? Oh my god, I saved it. Okay, leave it. Now, so the problem with the full mesh, right? The problem with the full mesh, we need to do the lots of configuration. The problem with the full mesh, we need to do the lots of configuration on every single auto. Can you imagine if you have 100 plus sites, then how many universities we are going to maintain over there? Full mesh never recommendation. Even full mesh is never recommendation to use the full mesh anywhere. It's never recommendation to use the full mesh. So to avoid the full mesh, what we can do over there, we can make a router header. So now, as compared to this topology, this one, I'm going to convert this topology into the this one. So now we have branch router in the Delhi. We have Bangalore, Mumbai, and Hyderabad. Not this, yep. Like this and like this. So router number 1, 6, 7, or I can make a 2. And this guy is going to have a Delhi 1.0.0.0.0.0. This guy has a Mumbai 0.0.0.0.0. This guy has a 6, Bangalore, and this guy has a Hyderabad 7.0.0.0. So now I'm going to make, yeah.
One question. Sorry for interrupting. So
Yes.
now I just got confused. So now with this Lisp, right? So now imagine if there was no underlay at all, sir. And I just,
if you don't have underlay, you cannot achieve the overlay network. Never ever. Your reachability must be there. This reachability must be there. This one to this one. The public network reachability must be there.
okay. So
If you
that's
don't
that
have-
redistribution, everything has to happen, correct? No, I
all
mean,
the-
like at least the OSPF stuff has to be exchanged.
Of course, this public information has to be exchanged anywhere. If you do the GRE, DMVPN, anything, even in the SD-WAN overlay network, you're going to create, right? Anywhere, if you're going to create the overlay, you must need to have a correct underlay. If your underlay is not working fine, you cannot achieve the overlay. For example, if this link goes down, take example, what I'm trying to say, if this link goes down, right, this underlay, this architecture also will be down. This will be also down.
Okay.
Is the
Because
underlay-
when we create an IPsec tunnel, right, we can directly exchange connectivity between Delhi to.
Still no, but in this case, in that case also, what happened? We're still dependent on the underlay. Just tell me one thing: can you make your flat or a home in the air? No, you cannot make. You need a land, right? On a land, you need to create our homes or any architecture you're going to do on a land. You cannot put your home on the virtualized, right? Same thing. This is my land over there, right? We need an underlay network to achieve the overlay. To get the overlay, you must need to have a good underlay. If you don't have an underlay, you never ever achieve the overlay network. Yep. Question? No. Clear?
Does the underlay have to be in the same area, or does it really not matter?
Doesn't matter. You can make anything. You can make. You do one thing. You make a OSPF area 0 over there, right? You can run the BGP over there. You can run the EIGRP over there 100. You can run the ISS program. Doesn't matter. I'm not going to depend. The customer is saying that it's totally independent. I'm not going to depend on the service provider now. Anything you're doing, either you can take an MPLS connection, I'm going to take a frame relay, anything you can take it, no issue. I don't have any issue with that. I'm not going to depend. I just need to have a reachability. I just need to have a reachability between this guy to this guy because I'm defining the gig Ethernet. If you see the configuration, I think that the configuration on router number 1, right? Let's do one thing. Let's copy this configuration. I think so. This side.
So, but in IPsec, right, we use public IPs and the connectivity is through the internet, right? So
Yep.
that is a public.
So we also have a reachability,
here,
right? In the source and destination, we also had a reachability over there.
correct, but we are over here. We are using our internal IPs. I mean, like the private IPs to form neighborship, and then basically that is being used as an underlay here, correct? Using the OSPF.
Right, correct.
But what if the
But in the both case, what happened? Try to understand this thing. You're getting confused, right? In the both case, what happened? We have a reachability. Either you can do the DM VPN, either IPsec or the GRE, MGRE, GET VPN, any SSL VPN, any VPN. If you want to achieve the overlay network, you have to provide the reachability. So right now, what happened if you see the configuration? What I'm trying to say that from this guy. So I did this configuration on router number 1, right? On a router number 1, say the source will be what? My source will be gig 0/0, right? That 13.1. Destination is what? 23.2. So I need to have a reachability. If you don't have a reachability, you cannot achieve the overlay network. You cannot have a neighborship between this guy and this guy. See that? Let's do one thing. Let's do one. Okay, I'll do one thing. Let me clear the router reflector as well as. Then I'll come to the troubleshooting part.
Yeah, no problem, sir. Yeah,
that's
sorry for interrupting.
Because we have actually I have lots of things about the EIGRP over the top, right? Actually, I have a policy things as well as. Okay. Now, how the RR will work in this case? Try to understand. This is the amazing concept of the EIGRP over the top. In this case, what happened? Try to understand. This is my topology that I'm going to create. From the full mesh, we are moving to the router reflector. Now what happened? R6 is going to share this info. All the client is going to share the information to the router reflector. All the client is going to share the information to the router reflector. Own information. So R6 will share the own information. R7 will share the own information, and R2 will share the own information. What server is going to do in this case? Route reflector. The term is saying that, hey, let me reflect the route. Let me reflect the route. So whatever the route that R6 is sending to the R1, R1 will just reflect this information to the R7. R1 as well as. So this information to the 6.0.0.0 sent to the R7 and 6.0.0 sent to the R2 as well as. Same way, whatever the route that R2 is sending to R1, 2.0.0, this will be reflected to this guy, and this will reflect. It's pure like a server, right? If you remember the IBGP, dynamic neighborship, in IBGP dynamic neighborship, what we are doing over there? We are just opening the port number 179, right? And just putting the 0.0.0.0.0, right? If anyone is coming, you can put the own network as well as, for example, put the 192.168.1.0. So only from that network, the person can the router can accept the packet, right? Same thing I'm doing over there, nothing else. I'm just going to make R1 as a router reflector. So every client will send the information to the router server, and server will just reflect the information to the other client. But do you know the good thing? The good thing is that, okay, before I'm going to move this point, I'll let you know about this point first of all. The default behavior of the EIGRP. Right? If you have 1.0.0.0, so when R1 will send this information to the R2, in this case, what happened? What will be my next one? My next one will be 12.1, right? So in the R2 routing table, we have a D. Next one will be 12.1. What is the default behavior of R2 or EIGRP? By default, EIGRP router just change next. So what R2 will do? R2 will send this update to whom? R3. With the 23 dot. This is the default behavior. Okay, this is the default behavior. So in the R3 routing table, we have information like this. Guys, tell me, is it good or bad? In this topology, it's good. It's good. But tell me, in this topology, is it good when R6 is sending the update to the R1? When R6 will send the update to the R1, which update 6.0.0? Next will be what? 56.6, right? This is the IP address of this guy. R1 will receive this information. R1 will maintain this information with the 6.0.0.0 with the 56.6, right? Tell me what R1 will do in this case. Default behavior. Listen to me carefully. If R1 is going to share this information to the R7, if R1 is going to share this information to the R7, by default the next stop is changes, right? So R1 will send this update like this. So the IP address of this person will be, take example 17.1. So R1 will send the update like this to the R7 6.0.0.0 with the next hop 56 dot, not 56 dot 17.1. Bad thing, you know what happened in this case? See, I'm not denying it's a bad, right? You know what happened in this case? If you say the ping, the packet will go via whom? Like this. सांप बना दूंगा मैं इसको. Can you imagine if you just want to go from the Bangalore to Kerala, right? In between we have a Delhi is over there. How the communication will happen? I want to go to the Bangalore to Delhi, from Bangalore to Kerala. My communication will happen like this. Is it a good thing? No. In that case, what happened? We need to disable this behavior. The command I need to tell this router, no IP next. Actually, the IP will be not there. This IP command is required in the classic mode, right? If you want to change this command, IP no IP next stop. Next stop, no IP next stop. So this command is for the classic mode. If you're going to do in the classic mode, and if you do for the name mode, so you just need to put the no next stop. So first command, this one. Second command, second thing, you tell me one thing. You tell me one thing. Second thing. Right now, how many interface? This is the RR, right? Right. So in the RR, how many interface we have? 0/0. So R6 will send this information on this interface. So R1, this router 1 will receive this packet on which interface? Gig 0/0, right? R1, listen to me. R1 is receiving this 6.0 update on which interface? Gig 0/0. Am I able to send the same update to the another guy? By default, not. Why? Second problem. So to avoid this, in this case, what happened? The route reflector has a complete information, but route reflector cannot share the another information to the another guy, right? So in this case, what happened? You need to disable the split horizon rule as well as to achieve the route over the top OTP route reflector. You need to disable two things. One, you need to disable the no next stop self, so that router one will not put on next stop. Second, no IP split horizon rule, so that in this case, what happened when the router number one, or we can say that a route reflector will receive or any information from client, they can advertise the they can advertise that information to the another client as well as. So two things we need to disable. So we just need to go on the router number 1 first of all. I'm going to make this guy, like let's take example. In my case, let me disable the EIGRP first of all, right? Okay, I'm not interested. No router EIGRP number 1, no router EIGRP NH. Oh, sorry. So my peer has terminated, right? No router EIGRP NH. Today I have no router EIGRP NH. Enable. No router EIGRP NH. I've disabled the EIGRP now. Let's run. I'm going to make this guy as a server. So every router is going to form the navigation with this person, right? So let's go on a router number 1. So router number 2 first of all. What happened? So once I disable the EIGRP, what happened? The OTP LIPS also will be disabled, right? So I say router EIGRP over the top, right? Address and IP for autonomous system 1. And I'm saying the neighbor, I'm going to form the neighborship with whom? I'm going to form the neighborship with the 1303. So every router is going to form the neighborship with the server. Which source I'm going to use? Gig 0/0. You can use any one of them as well as. It's totally up to you. So if you're going to use any of the interface, that interface should be reachable. Make sure that. If you're going to use any of the other interface except this guy, for example, I'm going to use the loopback, I'm going to use the another source, that source should be reachable. Then I'm going to say that remote will be, I can define the hops, you can define the hops from the 2 to 100, I can go for the fifth, and I say the lips encapsulation, I'm going for the ID number 1. That's it. That's it, nothing else. My lips interface will be up. Now let's go for the router number 6. So I said to do the same configuration on every router. So do show run section EIGRP. I'll copy this guy. Okay, go on router number 6.
Sir, you didn't tell why that network 20.
I'm coming to the point as well. Just give me. I have never. I didn't forget. I'm coming to that point. All good. If you're not for your right now information, if you're not going to advertise that in network, the directly connected network, your OTP will be not work. Why this thing is happening in this this PNet, I'm going to tell you. So now I have done with the configuration on every router. So every router has the same configuration. Every router is going to form the neighborship with the client router filter server, right? Let's go back to the router number 1. And I say the router EIGRP OTP address family IPv4 auto system 1. Now I'm going to use the remote. I think so. Remote neighbor. 1 minute, guys. I think so. Command I'm yep. Yes. Remote neighbor, right? I'm going to say, so what will the source? My source will be my gig 0/0, right? This is my source. If any person is going to make a remote connection with me, if any person is going to make a remote connection with me, you need to make a remote connection with which person? Gig 0/0, right? That's my source. And it's the same configuration I did on every router. If you see on a router number 7, on a router number 7, what happened? I defined the address of which guy? This source. On every client, I need to define the address of which guy? This source, right? So I need to tell this person on R1, hey, do one thing. Whenever some person is going to make a remote connection with you, right? Whenever some person is going to make a remote connection with you, you need to accept the packet on which person, right? Or we can see that whenever you're sending some packet, whenever you're sending some packet, your source will be gig 0/0. After that, do I need to do for the OTP for unicast or multicast? I'll tell you one thing, guys. When the OTP has introduced, I think so in year 2013 or 12, I am 100% not sure, nearby around that 13 and 14. On that time, OTP was only introduced for the unicast, as I seen somewhere, right? I'm not confirmly sure, but yes, on some docs I have seen this thing. Like it was only introduced for the unicast on the time, right? When they have launched the Cisco, when the Cisco, and this features has introduced by the Cisco. Okay, so when the Cisco has introduced this feature, they have only introduced for the unicast, but now they have converted into multicast. This information has given according to the docs. I'm 100% not sure, but now the time it is support for the unicast and multicast as well as. Okay, so right now I'm doing the unicasting. I can go for the unicast solution, and which lives in capstone protocol. I'm going to use the one and hit enter. Can you see my neighbor is getting up now? So now if you see, router number do show IP EIGRP neighbor, I have a good to go. Every neighborship I have. And if you go to router number 1, I say the network 1.0.0. Okay. Router number 6, network 6.0.0.0. And router number 7, network 7.0.0.0. And on router number 2, I need to advertise my own network 2.0.0.0. What happened in this case? R1 will accept the update. Do show IP route EIGRP. Do we have all this information? Right? What about the R2? I don't have the information. This is the reason just because of the split horizon rule. Just because of the split horizon rule. So what happened? I haven't disabled the split. By default, split horizon rule is enabled, right? So if you go back to the router number 1, and if you just see show interface, I think so. Can I get the LIPS information? Yeah, do show IP interface LIPS. No, I don't need to see the LIPS. I need to disable the, because I'm receiving the packet on the gig 0/0. I need to see on the gig 0/0. Can you see? By default, the split horizon rule is enabled. And that is used for the loop prevention, right? So right now what happened? R2 is only getting the 1.0. That's from the server. But server has a complete information, right? Server has a complete information. Server has a complete information. Again, if you go for the another client, router number 6. So router number 6 has only the server information. They don't have a client information. Only server information they have. So in that case, what happened? I just need to go on the router number 1. Interface gig 0/0. No split horizon rule. Graceful restart is happening, resync of the split horizon rule, right? Now, if you go back to the router number 6, previously it was only one information, right? Now, got all information. What is the problem is happening? My problem is very simple. This guy. Next stop is study node 1. You want to send the packet. Oh, I made a mistake. I need to send the packet to the different. But for example, go on router number 7 and show IP route to EIGRP. Trace shot I'm going to make. I'm going to make the 2.2.2.2 source. Can you see the problem? If I'm sending the packet from here to here, try to understand. If I'm sending the packet from Hyderabad to the Mumbai office, what happened? The traffic flow is having look like this right now. Then this guy, because of the next hop behavior. And who is studying node 1? This guy. right? So what I can do, I'm just going to simply on router number 1, and I've said that no next option. Now have a look. Previously, the routing table of R70 was pointing to whom? 13.1, right? 13.1, 13.1. Now, according to this guy. Now, if you're sending the packet to this person, single hop. Can you see? This is the benefit of the EIGRP over the top as well as. You can reduce your configuration. Only in one thing you need to do. Let me do one thing. I'll paste this configuration. Do show run section EIGRP so you can correlate. So this configuration was for full mesh, right? This configuration was for the full mesh. So on every router, you need to define the configuration. This configuration you need to define on every router. Only you need to change the right. Only you need to change the IP addressing over there, right? According to the router. For route reflector, we have a configuration like this. Okay, one minute, let me reduce the size. All good. One minute. One minute. I'll make this live so that you can easily correlate it over the space. All good, right? So this is the configuration for router. Let me know if you have any questions in the configuration line. Configuration is correct, I think, right? Everything's good.
I
This
think
thing,
to enable 23.2 remote file has to have that Lisp encapsulation one, right?
yep.
I
It has
think
to be
the
same.
first
It has to be same.
Yeah, on the 23.2, I think it's missing.
Okay, it's missing. Okay, it's missing.
Yeah, okay.
So now, guys, what I'm going to do in this case right now. So right now, if you see router 1, right, that's my route reflector server, right? R1 is forming the neighborship with every person, right? Do show IP HRP neighborship. I can limit this thing as well as. I can say that, hey, you do one thing, you're only going to form the neighborship with the 2%. And how do I do that? I just need to apply the some policies. I said, hey, do one thing, only max limit is, you can put the max limit from the 126.5.5.3.5, but I said only 2. My neighbor has goes down. 56.6 is not forming the neighborship. The last neighbor has down, right? The last one from the top list. From the top list, the last neighbor goes down. This is the top list, right? This one is top list. Why? Just because of the. So it's not like that R6 is not trying to form the neighborship. R6 is trying to form the neighborship. He's sending the hello packet, but he's denying, right? He's denying. R1 is denying. He's sending the hello packet. Right now, what happened? This guy. I just say that max limit is 2, right? So R2 is forming the neighborship and R7 has a neighborship. But when this guy is sending the packet, this guy is drop. R1 is dropping this packet. So you can limit, you have a range from 1 to 6.5.5.3. You can also limit this thing. But for example, in this case, what happened? If you see the problem of this case, max limit. If I'm going to just take example, if I'm going to just shut down this guy, right? R2. If I'm going to shut down this guy, interface 0/, let's say shut down the complete EIGRP process. I'm going to shut down this guy, right? So I made a graceful shutdown on R2. Now what happened? R1 is forming the neighborship to whom? R6 now. Can you see? Why? Because now R1 has lose the neighborship with R2, right? So they have a limit only 2. So they can accept that this guy right now. They can accept the, because now previously R2 has a neighborship with R1, right? So the neighborship has down. So now we have a 2 limit. In the 2 limit, what I can accept the packet of this person. I can accept the packet of this person. If I'm going to up this interface, for example, this was my primary source, right? Not a primary, so this was the main branch we have. If I'm going to up this guy, still what happened? R2 is not able to form the neighborship. If I'm going to up this guy, let's say no shutdown. So R2 is going to try to form the neighborship with the R1, but he's denying, right?
Law, that's like that's not really how many hops your neighbor is away, right? It's more like an accumulative hop count, right?
Sorry, cable hopper in the sense?
Like an accumulative hop count with all the neighbors combined. That's what it looks like.
Yeah, it is look like, right? Exactly. It look like, but actually it's not. But do you know what happened, guys? Try to understand. In this case, if you're going to define the maximum rate, you can define it, right? So in this case, what happened if some other person is not going to make a connection with you, right? Some other person. But this is not a feasible way, actually. You can do that, but it's not a feasible way. You can do one thing. Let me remove this guy. So right now, every dot is going to form the neighborship, right? Do show run. So if it's 23 also forming the neighborship, right? Remove the command. You can do one thing. I say that neighbor lives in capitals and put the question mark. You will have an option of allow list. In the allow list, I'm going to call the any ACL number. I'm going to call the ACL number Cisco, right? And what I'm going to do, I'm just going to create a one ACL IP access list. I'll go for the standard Cisco. What happened? I'm going to see the permit. Which person? 23 or 2? 23 or 0, right? And I'm going to call this guy permit 56.6. Done. Exit. So what happened now? R7 will not form the neighborship with the R1. Can you see? Do show IP EIGRP neighborship. I just have a neighborship with the 2, right? So R7 is denying. R1 is denying the R7. Why? Because of the issue. So you can enhance the security like this. You can enhance the security like this. So whatever the EIGRP OTP is there, so it's done from my side, right? Now let's come to the troubleshooting part, right? So you have seen the packet flow as well as the data plane and control plane as well as. Now try to understand what happened on a router number 2, right? Or not a router, just go on the ISP side. On ISP, what happened? I'm just going to down this interface. I showed that the underlist should be fine, right? I'm just going to down this interface. I think give 0/1, right? Yep. Hold on, I'm expert. 3 seconds, 1 second. Neighborship goes down. Because we don't have rigidity. Can I ping from R1 to this guy? 23.2. No, I can't ping. If your underlay is not fine, how can I achieve the overlay? So if I'm just going to up this guy now, so my network, no, I don't have a neighborship right now. We have just a neighborship between this guy to this guy. We just have a connectivity like this right now. This thing I have denied through the ACL. I have a neighborship like this, and this thing is down just because this interface is not working fine. So this neighborship has down just because of this neighborship. This interface is not working fine, right? So underlay should be fine. So if you're just going to up this, yep.
Can you just show me that ACL again, please? One, sorry for.
Yep. I have called the single IP 56.6, and I have called the complete network as well. So I've told you the two different ways.
And where did you apply that, Cisco? In the named one?
Yeah, always same in the command line, in the remote name. This one.
Oh, allow list Cisco. Okay, got it.
You can also use the maximum neighbor over there. So I remove the maximum neighbor. You can use 1265535. I remove from there, and now I use this one.
Okay, yeah, thanks.
So now if you're going to up this guy, let's take example. I'm going to up this interface. It's already working fine now, right? So if you go back to the router number 1, all good, right? So you have an neighborship. All good. Let's do another task. On R6, right? Enable show IP EIGRP enable. I have a neighborship with the R1, right? Okay. Router EIGRP. 1 minute. Do show run section EIGRP. So this is just a troubleshoot that I'm going to show you right now of the EIGRP over the top. How do we do that? Let's do one thing. Let's me copy this guy, and I said no network 56.0. This is the, I'm telling you, this is the, I think so. This is the bug of the PNet lab. This should be not advertised automatically. Okay, you do one thing, do this practical, right? Do this practical in the web IO, okay, and check this behavior, right? Is it work? Is it seem like he's doing like PNet lab EVNG, right? Because I haven't configured this thing, but it's advertising. But the requirement is that it has to be advertised. Why? Because if you're not going to advertise, how does this interface will understand the EIGRP packet? How does this interface will be understand this EIGRP packet? So in that case, what happened? You need to put the network statement to enable this interface so that it can understand the EIGRP packet. So if you're not going to enable, what happened? See, I have removed the no network, right? Can you see what happened? My EIGRP has down. You have to advertise it, but in the PNet lab, what happened in this lab? It's already by automatically they are advertising. I think so. Maybe I'll do one thing. I'll check this thing in the VMware so that I'll confirm myself as well. I think so. Maybe it's a bug, or maybe this is the default behavior of the OTP, and it has to be advertised. If you're not going to advertise, if you see that my neighborship has down. If you see, my neighbor has done because we are not enabled, because this interface is not enabled in the EIGRP. So if you just have a look, I can, where's the name here? Take some time. I'll do one thing. I have a lab configured in this one as well as, so just so EIGRP over the top. Devices. I'm not interested in the complete network, so I can do one thing. I'm just checking this behavior. Is it the bug of the PNet or like it's a default behavior? But if you're not going to advertise, your interface will be not enabled. If your interface is not enabled, you cannot achieve the OTP. Because to understand the hello packet, you need to enable the interface, right? EIGRP. Enable show run section EIGRP. Do we have a configuration? No. So let's do one thing. Routing EIGRP number CCIE. Okay, 1 minute. Good. Routing EIGRP number CCIE address on the info from system one, and let's say the neighbor. Take anything. I'll say the 23 or 2. 3. I can go for like how I can say the remote neighbor. Okay, gig Ethernet just last gig remote. I have one lips encapsulation, right? Exit, exit, do show run section HFP. It's not doing, guys. It's a bug of the this event. This is the bug of this. It's not doing everything. Okay, so the bug of this. So you need to, but you need to advertise this guy. If you don't get address, it will not, never enable the interface. So let's do one thing. So if you see right now, we don't have a neighborship, right? Do show IP HFP neighbor. I don't have a neighborship. It's recommendation to enable. So let's enable it. This interface 56.0. This physical interface, right? This physical interface I'm talking about right now. 56. This one. So you need to advertise this route, right? This is directly connected. So in this case, you just need to advertise this information, right? You are not going to enable the EIGRP on the service part, not. Just need to advertise this into so that it will send the hello packet. You can understand this thing. So now if you see, I have a neighborship. Good to go. Another thing I'll show you. I'll say that no, I'm just going to remove this person. Okay. So it has to drop the neighborship, right? Neighborship I'm going to form with the 13.1, gig 0/0, remote. Sorry. One minute. 13.1, gig 0/0, remote will be 2 lips in caption room. How many hops I defined? 2. So if your hop is not even reachable, right? Because it's a not a 2 hops away, it's a beyond the 2 hops away, right? Can you see that? Physically, it's beyond the 2 hops away. So if you're not going to define the properly hops, in that case also what happened, they will not form the neighborship. So how many troubleshoot we have till now in the OTP? So first of all, advertise the directly connected route so that the interface will be enabled in the EIGRP, right? Okay, second thing, remote hop count. Configure correctly, right? If you're incorrect, remote hop count will be there, neighborship will be not work. Third thing, check your ACL. Sometime what happen if you're not forming the neighborship, ACL will be configured, the allow list configuration, right? Check your maximum limit over there and check your underlay. That's the most important. Right, encapsulation. I didn't check this one, the LISP separate identifier. Okay, you can do one thing, you can check this one as well as. So this was the possible issues, the 1, 2, 3, 4, and 5. Check ACL in the sense of what allow list, right? Allow list ACL that I did on this guy, right? Same one. Sorry, allow list this guy. All good. So this is how you guys you can troubleshoot and the OTP. Now I'll tell you the conclusion point of the OTP. See, if you have EIGRP domain, right? If you're implementing the EIGRP in, for example, this is my company, right? So there's one branch, another branch, another branch, another one. Doesn't matter how you took the ISP connection. Doesn't matter. Is it the MPLS, BGP, or anything? Doesn't matter. If your service provider is going to, if the customer is going to run with the EIGRP, if the customer is going to run with the EIGRP, if the customer is going to run with the EIGRP, the customer is going to run the EIGRP, and you don't want to share the LAN information to the ISP. So you have a multiple option. You can use the GRE, you can use the MGRE, you can use the DMVPN as well as to make a overlay network. You can create a OTP in this case, as compared to the GRE, MGRE, or DMVPN. You can create the OTP. No need to do the lots of configuration of the DMVPN. Can you imagine how many configuration you have in the DMVPN? It's huge configuration. You need to first configure the MGRE, then you need to configure the NHRP protocol, this thing, right?
But of course, Cisco's
OTP,
going to give us the DMVPN because there's a huge configuration. They're not going to give us this.
exactly right. Can you imagine? Have you seen that the DMVPN configuration? And it's a huge configuration. Can you see the over the top? What over the top is providing? It's code completely transparent your service provider network. I'm not going to set a single information to the service provider. But you know the thing is that, see, I can't tell you like you have to use only OTP in your production if you have implementation of the EIGRP. It's totally dependent on the requirement, because the thing is right now in OTP, can we implement the IPsec? I don't think so till this point, because IPsec is why I need to secure. For example, I need to secure my data. I need to use the IPsec. So you can implement IPsec through the DMVPN, right? You can implement the IPsec through the DMVPN, but till this point right now, okay, as I has gone through the multiple docs, right? OTP right now is not supporting the IPsec, but I have seen somewhere that OTP will work with the get VPN.
What's that?
I have seen. I've said I've some gone through some docs. It was given over there, but right now I'm not 100% sure about this thing. Okay, I need to check verify this thing on more and more. But the simple way is that, like, if you need to achieve the overlay network, and if you have a if your router does not have a much resources, right, go for the OTP. Simple configuration. Don't need to go for the DMVPN and something like this. No need to go.
In a production environment, even though those are 4 branches, would the route reflector need to be a larger box?
Yeah, router reflector is configured. Say router full mesh is if you have 2 and 3 branches, 4 branches, you can do that full mesh, right? Router reflector is required if you have multiple branches, 20 plus near around.
So you would need to have a larger device at that branch, right? Larger.
Yep.
Yeah. Could you just show how you enabled the Wireshark again on the Eve?
Yeah.
I missed that. I'm sorry.
You know, you should just need to go on this guy and click on the right click and go in the capture and which link you have to use. So this link is enabled right now. I'm not good with the EVNG right so much. So this link is enabled the gig 0/0. So I just need to click on the right click on this guy, capture, and let's click on the gig 0/0. That's it. So if it's, for example, if you go for the route number 6, I go to capture and gig 0/0. It's going to take a load and we'll get the version. It's a little bit blue. Now I get the version. All good. Hey Jaydeep, it's clear to you? Your question was clear now, the DMVPN concept. Yep, thanks. So guys, it's you use this OTP features. It's good for the exactly right. Even I saw this thing. It is amazing. I for all of the comparison, right, all the DMVPN and GRE. That's one of the OTP is very good. Like if somebody will tell me, hey, do one thing, law, I need to create the overlay network. Okay, between the multiple branches. I just said, just give me the 2 minutes. I'll just configure over there. Just give me the 2 minutes. I'll just configure over there. Only the security features is missing, right? Yes, right now. See, I can't say that it's missing right now. To be frank, I'm telling you, uh, like I haven't gone through that like this concept, like VPN concept in the OTP. Like, does OTP support the IPsec or not? Let's do one thing. I'll do that for you as well as. But yeah, I have gone through some docs that are showing that it's supported. Does EIGRP support IPsec? Okay, yeah, this EIGRP OTP support the VRF as well as, yes, VRF they are supporting, or eVPN also supporting. eVPN also supporting by the OTP, right? So, but I don't think so. I need to go through that. Okay, then I'll let you know. Don't worry about that. Okay, I need to. I think so. It's not supporting right now. It's not supporting, right? Even do you know the DMVPN is also not. DMVPN is by default. DMVPN is not supporting. You need to implement the IPsec of the DMVPN, right? So if you just compare with the DMVPN or the OTP, I'll go for the OTP. If you just need to provide the overlay connectivity between the this branch location, the this branch location, I always go for the OTP. If you don't need a security, right? If you don't need a security right now, go for the OTP. Okay, guys. So hope this thing is clear to all of you. If you have any questions, you can ask me. Right? I'm done for today. Anyone any questions? uh, please share the number to support. Please share the number. Yeah, actually I'll send you the number, right? In the CCI lab group. So in the CCI group, right? My number is off right now, so I'll just go my home and I will send you the number, right? So you just call that person. He will help you to install the EVNG, and if you need a peanut lab, he will install you, right? Okay.
Eve has in their documentation, they have a PDF called the cookbook. It
Yeah,
explains everything.
that's yeah, this cookbook we are asking about. Like, no, I think so, I had somewhere, I had a cookbook, right? That's like if you want to install your like SD-WAN topology in your EVNG, then you can follow the cookbook. You can share the Sagid number as well as Jadip. Yeah, Sagid will help. You can share the Sagid number. All good, guys. So do one thing, spend your whole night with the OTP. Okay, and I'm telling you, you will feel very like very happy with after doing the OTP labs, right? Even like I'm telling you, like it took me lots of the time because some router was not supported. I made the 2 and 3 practicals of this thing, right? So the router was not supported the commands, everything, right? So after a long time, I did this practical. Almost 2 years back, I did this practical, right? Okay, and then after now I'm teaching some to you, right? Before that, I think so. One CCNP person, I taught this person. He said, okay, I need to learn the OTP. Okay, so do this practical. Let me know if you have any questions, right? Okay, the most important thing, only need to remember that LISP I'm just going to use over there, right? LISP I'm just going to use over there just for the data plane. Just for the data plane, that's it. Okay. And OTP support the unicast and multicast as well as nowadays. So this is my topology, underlay topology. After we create the full mesh, and after the full mesh, we create the router filter. So in this router filter, you need to disable these two features. If you're not, see, it's not recommendation, we can say that, right? It's totally of your requirement. But this one is a recommendation, no IP filter, and this one is a depend on the requirement. For example, if you now provide the hub and spoke topology, right? Hub and spoke topology. In that case, no need to disable. But if you know provide the spoke to spoke communication, in that case, you need to do this thing. You need to disable this thing. Okay. So, guy, by the way, it's long.
One question, sorry.
Yeah.
So, like the named mode and this classic mode, right? We did a lab on GNS3, correct? And it was supporting it, correct? When we did the named mode. So, what is the challenge in this one not being supported? I don't understand, because even I
Command, the
did the
remote
classic mode.
remote command is not supported. The LIPS
Okay.
command is not supported over there. See. So this is my router on, and if you just go router, okay, this is my 15.0 15.0. क्या हो गया था जिंदगी में? क्यों परेशान है? 8 लाख की पैकेज लगी है तेरी हैं? तुझे इतनी कम एज में इतनी पैकेज नहीं लगती किसी की।
कम एज क्या कम एज है मेरी 28 पूरे हो गए।
28 हो गया। You know, Swami Ravin got a job with the 8 lakhs of package. You know, party. Then do one thing. You just need to come to the network. He's giving the party tonight.
Awesome. Congratulations.
इसकी लगी पैकेज ले से पार्टी तू ले ले पहले। एक मिनट जा। It's just a router EIGRP and the CCIE over the address family IPv4 auto system 1. And I'll go for the neighbor. Just have a look over there. 2303 with a question mark. I'll use the source interface faster than 0/0. Do we have a remote keyboard over there, Swami?
Okay.
Got it?
Mhm.
You don't have any options, right? You do one thing better to go the whereby you write that option is available in the whereby you can go for the PNIC. Okay.
Okay. Yeah. Thank you.
All good. Okay, guys. Bye bye.